Alright, this lesson is about solving special triangles, 30, 60, 90 and 45, 45, 90 triangles. So in problem number 1, this is the short leg. So that means this side is going to be short times radical 3, and this will be 2 short. So we already know the short leg, so we'll put that here and we'll put this here. So this is going to be, of course, 8 radical 3, and this is going to be, well, 2 times 8, which is 16. Alright, number 2. This is a 45, 45, 90 triangle. So, of course, this is the leg, which will be the same as this leg, and this will be leg radical 2. We can solve this one by dividing by radical 2, and that's going to give us that the leg is 5 radical 2, which of course means that x and y are both 5 radical 2. Okay, number 3. This is a leg, and this is a leg, and this will be leg radical 2. So that means, since the leg is 7, then that means x is also 7, and y will be 7 radical 2. Number 4. This is the short leg, so this will be 2 short, and this is the one we really need, short radical 3. Because of this 8 right here, this means that 8 equals short radical 3. But we can divide this by radical 3 on both sides, and that's going to give us that short is equal to 8 radical 3 over 3. So that tells us x right there, because x is the short side. But then y is 2 times the short side, so that's 2 times 8 radical 3 over 3. So that means that y is going to equal 16 radical 3 over 3. Number 5. This is the short side, so this is short radical 3, and this is 2 short. Okay, but this side is 10, so that means that short radical 3 is going to equal 10. So we can solve this side by dividing. So that's going to give us that the short leg is 10 radical 3 over 3. So again, x is the short side, so that gives us x. and y will be double that. So the y value will be 2 times 10 radical 3 over 3. Okay, basically just plugging this in right here. 2 times 10 is 20, so y is going to equal 20 radical 3 over 3. Number 6. Alright, this is another 45, 90 triangle, and we're given one leg, so that means this other leg will also be 13, and the hypotenuse, this y, will equal 13 root 2. Number 7, this is the short leg, so I'm just going to call that short. This side is going to equal short radical 3, and this side will be 2 short. So if the short side is 20, that means this side is going to be 20 radical 3. Alright, so that's x. If short is 20, that means this side is 2 times 20, which is 40, of course. So that's going to be y. Okay, number 8. See that 18? So this is leg, and leg radical 2. See how the 18 is in the same position as the leg radical 2? That means that leg radical 2 has to equal the 18. Of course, I could solve this by dividing both sides by radical 2. So those are going to cancel each other out. And that's going to give me leg equals 9 radical 2. Okay, so that's x and y right there. So that means x equals 9 radical 2 and y equals 9 radical 2. Alright, looking at number 9. We got a 30, 60, 90 triangle here. That's the long leg. So this is the short leg. This will be 2 times the short leg. And this right here where the 15 is going to be short times radical 3, because that's the long leg. Focus on the 15. The 15 must equal short radical 3. So I'm going to write that separately over here. So short radical 3 equals 15 because of this. Of course, I could solve this equation for short by dividing by radical 3. So that's going to give me that the short side is 5 radical 3. Okay, so that gives me x, because x is also the short side. So I wrote short up here, but these are the same, so x, so that means x equals 5 radical 3, being the short side, and y is going to be 2 times the short side. So y is 2 times 5 radical 3, which is 10 radical 3. Okay, now that brings us to the little word problems on the back. Let's definitely draw these pictures. The perimeter of a square is 20. Okay, the perimeter of the square is 20. So that means this is 5, 5, 5, and 5. Find the length of the diagonal. Well, the diagonal will be like this. So this is going to be a 45, 45 triangle, 45, 45, 90. So it goes leg, 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 radical 2. So the diagonal will be 5 radical 2. For number 11, the altitude of an equilateral triangle is 18. Find the length of a side. Okay, so here's our equilateral triangle. And the altitude was 18, so here's my altitude. Alright, so the altitude is 18. We're supposed to find the length of a side. So basically we're looking for the hypotenuse over here. Well, it goes like this. This little part right here is short, and when I say that, I'm just talking about this part only. Of course, where this 18 is short root 3. Short radical 3 is the 18. Okay, so I've got short root 3, and then the hypotenuse, which is what we're really looking for, as always, will be 2 times the short leg. We have to use the only number we're given, the 18, but as you can see, the 18 should equal short root 3. They are in the same position. So I'm going to write that over here. Short times radical 3 should equal 18. So as always, I can solve this equation by dividing both sides by radical 3. I'm just going to leave it blue. So that's going to tell me that the short leg is 6 root 3. Okay, but if the short leg is 6 root 3, I could put that in right there, and that's going to tell me that this is 2 times 6 root 3, which is 12 root 3. And remember, that is what we were looking for, the length of a side. So this equilateral triangle is 12 root 3 on all sides. Okay, number 12. The hypotenuse of an isosceles right triangle is 16. An isosceles right triangle is our familiar half of a square. Okay, so here's an isosceles right triangle. Because this is isosceles, we know this is a 45, 45, 90 triangle. The hypotenuse is 16, so we know that this is 16. Find the length of a side, so we're looking for the legs. Okay, so like we always do, we will label everything with the expressions. We have leg, leg, and 16 should equal leg root 2. This is an equation I can solve by dividing both sides by root 2. So that's going to give me that the leg equals 8 root 2. And that's what we were being asked to find, the legs. So we're done with that one. Okay, and finally number 13. The length of the diagonal of a square is this. Okay, so that's almost the same as number 12. Number 12, we're given the hypotenuse of this 45-45 triangle, but the diagonals of a square is also the hypotenuse of a 45-45 triangle. Whoops, meant to do a square. Okay, so here's my square. Here's the diagonal of my square. Well, one of the diagonals. And that diagonal is 5 root 2 over 2. So this is 5 root 2 over 2. So of course this is a 45-45-90 triangle. If I want to find the length of a side, again, that's I'm looking for the legs. So I'm going to do what I do every single time. I'm going to label with expressions showing the pattern. So this is leg, leg, and of course this will equal leg root 2. So I can solve this equation. I'm just going to write this off to the side. Okay, I'm just recopying this equation over here for a minute. So I've got 5 root 2 over 2 equals leg root 2. So if I want to solve this equation, as usual, I need to divide both sides by root 2. So I need to divide by root 2. Now, if I want to divide this whole thing by root 2, I'm going to let you in on a little secret. If you divide a fraction by something, that's the same thing as just putting that number in the denominator. So in other words, for example, say if I have a over b, and for whatever reason, so say if I had a over b equals, I don't know, 3x. If I wanted to get x by itself, I'd have to divide by 3. So I'm dividing by 3 on both sides, okay? But dividing this by 3 is the same thing as putting 3 in the denominator. So this would give me x equals a over 3b. So if you divide a fraction by something, all you really have to do is put it in the denominator. So dividing this fraction, 5 radical 2 over 2, by radical 2, all I really need to do is put radical 2 in the denominator. Alright, I'm going to show it the long way in a second, but this is the best way. So for anybody that's watching this video, that's a bonus for you. You'll be able to do this the easy way. So the radical 2 comes here, then you can quickly see that those radical 2's are just going to cancel each other out. And so that's going to give us that the leg is equal to 5 over 2. And that's what we were trying to find, the length of a side. We were trying to find the leg. So the answer is 5 over 2. Now, if I didn't let you in on that trick about if you divide a fraction by something, you just put it in the denominator, you probably would have tried to do this. Let me go back. So for a minute there we had 5 radical 2 over 2. Well, that's ugly. We had 5 radical 2 over 2, and then that was equal to leg radical 2. Okay, I'm just going back in time. So if I wanted to divide this by radical 2, you might have done this and maybe made a big fraction. So we're trying to divide by radical 2. So I'm curious what the TI-30 XS multi-view would do with this. And will it give us 5 over 2? So let's try it. Okay, so first, this is like a fraction within a fraction, so we just have to be really careful. Okay, so here, we'll hit our n over d button, we have a fraction. Now in the numerator of our fraction, we need a new fraction, 5 radical 2 over 2. So I'm already in the numerator, so I'm going to hit my n over d button again, and it will make a fraction inside of a fraction. So here's my 5 radical 2 over 2. Okay, this is a really cool calculator to be able to do things like this. And then in the denominator, I've got my radical 2. So I'm going to go radical 2. Okay, let's see what happens. Boom! 5 over 2. Okay, so even if you don't know my special tricks that allow you to do this just in your head, you always have your handy dandy TI-30 XS multi-view to help you out. Alright, that's the end of the lesson.